Okay, this is the second example. If you refer to tutorial, that will be example 3. So the first example show you have retaining wall, and at the back of the retaining wall, the material is soil. Now, what happen if on the top of the soil, we put surcharge, or we call it as load. Okay, moving forward, we look directly to the example. Okay, calculate the resultant active thrust on a vertical smooth retaining wall of height 5.4 meter, a uniform surcharge of 48 kN per meter squared is placed on the surface. So these are all the soil properties, and from this we need to work out how to go about if there is two consideration to analyze retaining wall. Okay, let's see on this example. Okay, you can start with draw the retaining wall first, and with all the properties and the measurement or dimension. So that is your retaining wall. At the back of retaining wall, of course, it is compulsory to have soil behind your retaining wall. And from the question, a uniform surcharge, in terms of drawing, you can draw the surcharge as UDL, or uniformly distributed load, and the value of this load is 48 kilonewton per meter squared. Okay, let's remind us the principle to do the analysis. First, draw the pressure distribution or stress distribution. Second, calculate stress or stresses. Number 3, calculate thrust or trusses. There's many. If you have more than if you have more than one truss, so you need to calculate all. Number 4, position, and number 5 will be drawing again. Okay, let's begin with drawing. Okay, what is the difference to consider with previous example? So first thing, you have this 48 kilonewton meter surcharge or load. So if you're thinking about the real case, maybe on the top of this retaining wall you put water tank, or you construct building, or you construct houses. Okay, first I suggest to transfer this load first. If you have surcharge, the transfer load is square or rectangular section like this. Okay, eventually your surcharge is represented by Q. Alright, so what we transfer is Q, and then because this load is inside the soil, it must be multiplied by KAQ. And then you must remember, behind this retaining wall there's also soil. So draw that rectangular section to represent your soil given by gamma H. And then because it's inside the soil, you must calculate or multiply by the coefficient, which is Ka gamma H. So you have the correct drawing right now, but then we must identify how many elements. We have 1 and 2. So we need to calculate based on these two elements. Okay, this case, because we have one layer, so you can calculate the value of Ka first. Ka is 1 minus sine phi divided by 1 plus sine phi. So the value of your friction is 30. Sorry. And then when you calculate this, you get the value for Ka is 0.333. Okay, because when you have more than one element, I suggest to make a table so that we can organize all the answer in proper way. Okay, this is the suggestion. So you can draw the table here. So item number 1. Okay, this one is item. After you calculate item, you can calculate for stress. And then calculate for active thrust. Calculate for position. And then calculate for moment. Okay, so consider item number 1. Okay, if you properly put the notation and correct notation at the base of this drawing, so you just take the value. Let's say stress A 1 is considered to element 1, so get the value of KAQ, and then calculate. KA is 0.333 multiplied by the surcharge, which is 48, and then you get this answer. Okay, and then you need to calculate for the thrust. Okay, consider the element number 1, the shape is rectangular, and we know that when you want to calculate thrust, okay, active thrust here, this is actually active thrust. When you want to calculate active thrust, that is the calculation of the area of your pressure distribution. So you have KAQ as the base, and then you have the height of the retaining wall, which is 5.4 meter. So rectangular section, base time height. So for active thrust, PA1 is the base. Okay, the base is actually stress A1, and then multiple by the height of your retaining wall. So get the answer and multiple by the height of your retaining wall. And then we get the value of 86,314. Okay, when you finish calculate the active thrust, let's observe the rectangular section. Okay, if you want to put the thrust, because of the rectangular section, we put the arrow at the middle of the pressure distribution. So that one is PA1, and because at the center, we know that the position will be 5.4 divided by 2. So you get the answer of 2.7 meter. Okay, I suggest to calculate moment, and I will explain why you need to calculate for moment. How to calculate for moment? It is actually PA 1 times the position, and then you get the moment value. So 86.314 times 2.7, you get 233.048. Okay, that is for the element number 1. Okay, next calculate for the element number 2. So stress A2 is equal to, okay, you get the value, or you get the notation for element number 2, which is Ka gamma H, and then get all the value to calculate 0.33. What is your gamma? Gamma is 20, and the height of retaining wall is 5.4. You get 35.964. Okay, let's observe the item number 2. What will be the shape? This is rectangular. This is triangular section. So the area will be half times base times height of the triangular section. So PA2 will be half stress A2 times height. So put the value and then find the answer. So we get about 97.103. Okay, then what we need to calculate is the position. So position now. Okay, right now is triangular section. Okay, you must put the arrow there. Okay, that is actually wanted from the height. So when you calculate, that will be what, 5.4 divided by 3, you get 1.8. Okay, again you need to calculate for moment for item number 2, that will be PA2 times the position. That will be 97.103 times 1.8, you get the value of 174.785. Okay, this is not end here. I suggest you to calculate the stress total, which is stress A1 plus stress A2. So you get 51948. And then for active thrust, okay, I suggest you get the total. And then we get 183.417. Okay, the total is PA1 plus PA2. Okay, which is 86.314 plus 97.103. Okay, so the answer is 183.417. And then you do this for moment. Okay, moment is M1 plus M2. You get 407.833. Okay, so let's check our checklist. Okay, already draw. We already calculate the stresses because of two elements. Already calculate for thrust. Okay, right now we don't actually know the position if we combine both of element 1 and 2. We know the position for each element, but for this kind of question, we need to know the position of the combination cases. So to calculate the combination, to calculate what is the position for combination item 1 and 2, okay, you can calculate using this equation: moment total divided by active thrust total. So you get the value of 407.833 divided by 183.417. So you get the answer is 2.22 meter. So right now that is for the total element. So next, okay, the checklist for number 4 is done. Okay, you need to draw. Okay, redraw is the combination of all loads. Okay, meaning that okay, we need to eliminate the number of 1 and 2. So you can draw like this. Okay, we know the position for rectangular here. And then we know the position for the triangular load there. So that will be the combination of the load. But basically we have few points here to highlight so that you can put all the information. And then the combination of both the two elements, you get the P total, okay, which is 183.417. And then you already know the position for combination, which is 2.22 meter from base. And then if you need to detail everything, so if the x-axis is the stress, you need to plot the stress. So this is zero stress. At the rectangular section, you have 15.1 984, and then when you combine both restless you get 51.948. So if you can draw this, so it completed things needed to calculate for this particular example. So this is the example. If you have surcharge, okay, you do the rectangular section and then you do the triangular section to represent the soil, and calculation as suggested, you get the answer, redraw, and then put all the value in your new drawing. That will be the final answer for this kind of question.